Intro to verifying trig identities. Okay, we want to verify this identity. What does that mean? Well, we're being handed an equation. We are already told that it is an identity. We're trying to provide a little bit of proof, a little bit of verification. Let's talk about how we're going to go about doing this. First, in terms of strategy, you have two options, and only two options. You can rewrite one of the sides of the equation until it matches the other, or you can rewrite each side until they match each other. Secondly, you have to work with each side independently. We're not solving equations here. There's no adding 5 to both sides. There's no square rooting both sides. Nothing like that. In fact, what I like to do is put a line right here in the middle where the equals sign is to remind myself I can't be moving things across that line. I am working with the left side alone, and I'm working with the right side alone. My tools are algebra as well as basic trig identities. And letter D, so important, there is no answer here. We already know this is an identity. The whole point here is showing the steps. If you skip a step, you have not verified the identity. So this is all about showing individual steps. Okay, let's take a look at this example problem. I'm looking at the two sides. I can't really think of anything that I can do with cosine x. I think I'll just leave that alone. Sine x, cotangent x, can I simplify that in some way? Well, let's see. Cotangent x, quotient identity, is the same as cosine x over sine x. Aha, and then the sine x's here cancel, and so I'm left with just cosine x. I have done the first of the two strategies. I rewrote the left side, and now it matches the right side. You are not finished in these problems unless what you have on the left is the exact same thing as what you have on the right. We've done it, so we've verified this identity. Okay, let's look at one that's a little bit more complicated. So I've got this fraction on the left. I've got a somewhat simpler thing on the right. I think I'll start with the one on the left. I see all those negative x's, and I know I have those negative angle identities. Let's see, cosine and secant are the only ones where the cosine of the negative angle is the same thing as the cosine of the original angle. So cosine negative x is just cosine x. Now, cotangent, though, that was one of the odd functions. That was one of the ones where when you switch to cotangent x, you get an extra negative. That extra negative then will plus out the middle part there. So I'll end up with plus cotangent x. And then the bottom, another cosine negative x that turns to cosine x. So far, I've just used a couple of basic identities there. Where should I go from here? Well, one thing that's nice is I can always glance over at the other side. I mean, I'm looking over here thinking there's no fraction in the end. There's only two terms separated by a plus. What that makes me think is maybe I should distribute this denominator on the right here into both parts. It's kind of like the opposite of adding fractions. It would be undoing the adding. Cosine x over cosine x plus cotangent x over cosine x. Obviously, I could put it back together because I have a common denominator, but this looks good because here's my 1, cosine x divided by cosine x. And then let's see, how about the other one? Maybe I should switch this to sine and cosine. So cotangent x would be cosine x over sine x. The bottom is already cosine x. I've created one of those complex fractions. The only little denominator is sine x. So if I multiply top and bottom by sine x, let's see, I'll continue here. Looks like the sine x's cancel there. And so I end up with 1 plus cosine x, and then on the bottom, cosine x sine x. Okay, now I feel like we're getting closer. I see that I have a common factor of cosine x that I can divide out on the top and on the bottom. That gives me 1 plus 1 over sine x. But wait a minute, 1 over sine x, that's cosecant x. Aha! The two sides match. That means we have verified our identity by rewriting one side until it matched the other. Again, we already essentially knew the answer here. The point of these problems is for you to demonstrate your ability to use basic identities and algebra step by step by step to obtain a desired result. Okay, let's look at one more. Again, don't cross over that line, right? I need to work with each side separately. This time, I think I'm going to have to do the second strategy. Both of these things look so messy. I think I'm going to clean each one up in the hopes that I can make a match along the way. On the right side, the denominator there seems calling out to be FOILed out. It's one of those nice FOIL problems. 1 times 1 is 1. The middle pieces go away, plus cosine theta and minus cosine theta. And then I end up with cosine squared theta from the end. And of course, as soon as I see that, it reminds me of the Pythagorean identity, right? 1 minus cosine squared theta, that's just sine squared theta. That's probably all I would do for the moment. I'm not sure if I need to do anything more. Let's switch over now and look at the left side. The left side also has a FOIL problem. It's a little bit hidden, right? But squaring that 1 plus cotangent theta is going to mean multiplying it by itself. And so let's do that. Nothing cancels out on this one. 1 times 1 is 1. The middles are both cotangent thetas, so I'd have 2 of those, 2 cotangent theta. And then the last would be cotangent squared theta. I have that minus 2 cotangent theta from the beginning. But look, now this 2 cotangent theta wipes out that minus 2 cotangent theta. All I'm left with is 1 plus cotangent squared theta. This is why learning those basic identities is so important, because 1 plus cotangent squared theta, that's a Pythagorean identity. That's equal to cosecant squared theta. But wait, 1 over sine squared theta, going back to the right, that's also equal to cosecant squared theta. We're done. We match. Again, until the two sides are exactly identical to each other, you are not finished. We rewrote each side until they matched each other, thus verifying the identity. Thanks for watching.